Automatic segment recognition. A nearest neighbor in paradigm, Keezers et al., 2002, is demonstrated to classify the segments obtained from the preceding procedure, described in section 3.2. To use the in algorithm, a distance measure between two segments is needed. The similarity metric QWX, Y, as defined in 7, between two segments, zond Y, is used as the distance measure. Thus, the closer two segments in L alpha beta space, the larger their similarity. Similar to a training process, a lookup table, LUT, has to be built under supervision to classify a given segment, Sj, into a known color group, C, i.e., C equals TSJ, I less than or equal to J, where Sj is a feature vector that distinguishingly describes each segment. C stands for a known color scheme, for example, sky, clouds, plants, water, ground, roads, etc., and is a classification function, i.e., a trained classifier. We use segment color statistics, for example, mean and deviation of each channel, as features, of 6 statistical variables. The statistical features, Sj, are computed using the diffused false color images, and the color mapping process is carried out between a false color segment and a daylight color scheme. The reason for using the diffused false color images here is because the diffused images are less sensitive to noise. In a training stage, a set of multispectral NV images are analyzed and segmented such that a sequence of feature vectors, Sj, can be computed, and the LUT, mapping, between, Sj, and, C, can be manually set up upon the experimental results. In a classifying, testing, stage, all QWXK, Sj, values, for j equals 1, 2, 3, are calculated, where xk means the current classified segment and Sj represents one of the existing segments from the training stage. Certainly, xk is automatically classified into the color group of the largest QW, similarity. For example, if QWX1, S5, is the maximum, then the segment of X1 will be colorized using the color scheme TS5, that is the color used to render the segment of S5 in the training stage.